Good morning to all. Today we are discussing about Nmos pseudo static random access memory cell. Okay, introduction. Pseudo static random access memory cell I show in figure. This is the circuit diagram of the pseudo static random access memory cell. Okay, and we know that SRAM is the example of the non-volatile memory. Okay, here we are using the pseudo-static RAM cell for storing the 1-bit information. It means that with the help of the circuit, we are storing the 1-bit information. Okay, and first point, two series inverter feedback in order to refresh the data periodically and hence holding data indefinitely as shown in figure. It means that in the construction of the static RAM cell, we are using the two pass transistors. Okay, the gated input of the one pass transistor is WR into phi 1 and the gated input of the other pass transistor is RD into phi 1. Okay, and here we are using the two Nmos inverters. Okay, and these two Nmos inverters are cascaded, and here we are getting the output. Okay, and again this output is given to the input of the this pass transistor. Okay, this pass transistor is acting as refresh the data. With help of this pass transistor, here we are able to make the one closed loop path. Okay, so here continuously we are refreshing the data. Clear? And the second point, WRR and RD are synchronized with the phi 1 clock and feedback transistor with the phi 2 clock. It means that in this circuit, this WR signal are synchronized with the phi 1 clock signal and RD signal is synchronized with the phi 1 clock signal and the gated input of this pass transistor is synchronized with the phi 2 clock signal. Okay, and third point, WR and RD must be mutually exclusive. Okay, it means that in this static random access memory cell, we are performing the two operations, that is reading operation and writing operation. So these two operations were not performed at a time. Therefore, we are considered these two operations are considered the mutually exclusive events. Okay, and now we are performing the write operation. Okay, so in this write operation, we are considered the WR into phi 1 equal to 1 and RD equal to 0. It means that in this circuit, we are applying the WR into phi 1 equal to 1 and RD into phi 1 equal to 0. So at that time, this T1 transistor is acting as a closed switch and this T2 transistor is acting as open switch. Okay, at that time, this bus we are considered data bus. Okay, and this data bus initially stored the information either logic 0 or logic 1. So here this data bus is store the logic 1 information. Okay, and here one important point is the data bus is acting as an input when we are performing the write operation and this data bus is acting as an output when we are performing the read operation. Okay, and third point, the bit stored on CG of the inverter 1 and will be reproduced complemented at the output of inverter 1 and true at the output of inverter 2. Mean that so the data is available in this data bus. Okay, the data bus information is given to input of this inverter. So this inverter have the gate capacitance. Okay, the binary information stored at this gate capacitance and output of this inverter is 0 and this output is given to the second inverter input and finally we get the output equal to logic 1. So here these inverter circuits have some gate capacitance. With respect to the gate capacitance, the binary information stored at this gate capacitance. Okay, so at that time this cascading inverter circuit is acting as memory cell. Clear? And fourth point, it will be seen that during every phi 2 of the clock, the stored bit is refreshed through the gated feedback path from the output of inverter 2 to the input of inverter 1. It means that after getting the output signal at the output of this inverter 2, that output is given to input of this pass transistor and this pass transistor is synchronized with phi 2 clock signal and we are assuming this phi 2 clock equal to 1. So this logic 1 output is again given to input of this inverter. So here our doubt is why we are giving the this output is given to input of this inverter. It means that with respect to this pass transistor, the exact output we are not getting at this position. It means that, for example, here we are giving the input equal to logic 5. Logic 1 is equal to 5 volts. Okay, the same output we are not collected at this pass transistor output. Because of with respect to the threshold voltage, some of the voltage drop will exist. Okay, so we are reproducing the exact information. So we are performing the this refreshed data process. Okay, and next we are performing the read operation. So when we want to perform the read operation, we are consider the WR equal to 0 and R into phi 1 equal to 1. At the time, this T1 transistor is off and T2 transistor is on. It means that in this circuit, we are assuming WR into phi 1 equal to 0 and RD into phi 1 equal to 1. At that time, this T1 transistor is off and this T2 transistor is on. Okay, and in the earlier stage, this memory cell consisting of binary information is 1. So when this T2 transistor is on, this binary information 1 is available at this data bus, and we know that within the read operation, this data bus is acting as an output terminal. So this logic 1 is available at this data bus. For example, in the earlier stage, in this memory cell, store the binary information is logic 0. So with respect to this T2 transistor, this binary information is available at this data bus. Okay, so in this way, we are performing the writing and reading operations in the pseudo static random access memory cell. Okay, and next we are discussing about CMOS pseudo static memory cell. Okay, so in this CMOS pseudo static memory cell, I show in figure. So this circuit diagram is similar to the Nmos pseudo static memory cell. Okay, and here we are replacing the Nmos bit with CMOS. Okay, so in this CMOS we are using the transmission gates. Okay, in this construction of the CMOS pseudo static memory cell, we are using the two transmission gates. Okay, and one transmission gate input is WR into phi 1 and other input is WR bar into phi 1, and the other input of this transmission gate is RD into phi 1 and other input is RD bar into phi 1. Okay, and here we are using the two CMOS inverters, and these two CMOS inverters are cascaded. Okay, the cascaded connection of these two CMOS inverters are acting as memory cell. Okay, and here we are getting the output, and again here we are using the one transmission gate for performing the refreshing data operation. Okay, and next we are discussing about write operation. So when we want to perform the write operation in the CMOS pseudo static memory cell, we are assuming WR into phi 1 equal to 1, transmission gate is turned on, the bit is stored as the gate capacitance in the first inverter as it is, and in the second inverter in the complementary form. It means that in this circuit we are considering WR into phi 1 equal to 1 and W bar into phi 1 equal to 0. Okay, at that time this T1 transistor is acting as a closed switch. Okay, and this T2 transmission gate is acting as open switch, because here we are giving the RD into phi 1 equal to 0 and this RD bar into phi 1 equal to 1. So this transmission gate is acting as open switch. Okay, and this data bus initially have the data is logic 1. So when this transmission gate is acting as a closed switch, okay, this data is given to the input of this CMOS inverter. So this CMOS inverters have the gate capacitance, so that information is stored in that gate capacitance position, and we got the output of this CMOS inverter is 1. And again, sorry, here we are giving the input is logic 1, the output is logic 0, and again that logic 0 is given to input of this inverter and we get the output equal to logic 1. Okay, that logic 1 is given to input of this transmission gate. Okay, this transmission gate is acting as refreshing the data. So here the purpose of the refreshing process is, here we are getting the output is not exactly outputs. It means that at the output of this transmission gate we got only 4.3 volts and 4.5 volts, but the exact output is 5 volts. So here we are performing the refreshing data operation. This exact output is collected at the output of this memory cell. Okay, so here we got the output equal to logic 1. For example, the data bus have the information is logic 0. Okay, when this T1 transmission gate is acting as a closed switch, okay, corresponding information is given to the inputs of this cascaded inverter, the output is equal to logic 0. So in this way we are performing the write operation. And next we are performing the read operation. When we are performing the read operation in the CMOS pseudo static random access memory cell, we are consider the RD into 51 equal to 1, transmission gate is turned on, the bit is stored as gate capacitance. The output of the first inverter is in complementary form and the non-complementary form output is obtained from the second inverter. It means that in this circuit, in the earlier stage, this memory cell store the binary information is 1. Okay. Here we are consider the WR into 51 equal to 0 and WR bar into 51 equal to 1. So this transmission gate is acting as a open switch. And here we are consider the RD into 51 equal to 1 and RD bar into 51 equal to 0. So this transmission gate is acting as a closed switch. When this transmission gate is acting as a closed switch, this binary information is available at this data bus. We know that in the read operation, this data bus is acting as a output terminal. So here we get the output. So in this way, we are performing the writing and reading operations in the CMOS pseudo static random access memory cells. Okay, thank you.